Oh, see, remember I was saying P9. If we go back, eventually we go back to the beginning of this packet. This is all review when we get there. That's just all. I'm supposed to teach it again. 150 beginning algebra topic. I'm supposed to teach it again. Okay, going though to chapter 3, the last section. So LOG is an abbreviation for logarithm or logarithm. It's pretty commonly spoken. Let's mess around with logs. I don't think, I've never heard it, or log functions. Let's mess around with log functions. Let's mess around with exponent functions. That's weird. Exponential functions is a formal, proper, about the only way I've heard it. So we abbreviate logarithms. See, there's how you spell it. Some people even spell it incorrectly. Challenging for me. I'm not a very good speller, but I think I can spell that if I had to. But logs is nice. So properties of logs, and there's infinitely number of bases that you can have. There are some numbers you can't have as a base. Remember that? There's rules. Let's see, a base, you can't have a base 0. That's weird. That's dumb. Numbers to have a negative base, that's impossible. Here, I'll show you. Let's say if I had log base -1 of, I don't know, 10 equals, I don't know. How do you convert this into an exponent version? You take the base, which is -1, you raise it to the x power, and that equals 10. How can I get -1 raised to a power to give you 10? Impossible. All right, well, Jeff, how about something else? I don't know. Let's see. 4. Let's see if I can create something that looks possible. LOG base -2 of 8 equals x. Okay, let's try that. So -2 raised to some power is equal to 8. Well, that's impossible. That's impossible. Okay, how about -8? Okay, that would be interesting. Yeah, well, okay, that could be 3. However, your argument, we've already, for the definition of logarithms, the -8 is called the argument. That can't be negative. See, so there's a lot of rules that you have to remember. Okay, fine. Go back over here. Here's the rules. Here's the rules. All right, here's the rules. Like right here. Okay, the base. The base can't be 0. It's got to be a positive number. It can be fractions. So for the definition of logarithms, for any of it, your number has to be a positive number, can't be 1. So it just can't be 1. And your argument, that's what this thing is, argument. The argument also cannot be negative, and it can't even be 0. Otherwise, we can't talk logarithms if it is, even though it looked like it worked. See, this looked like it worked back here with log base -2 of -8 equals x. It looks like it works. No, but this fails the definition. You cannot think that you could make up any math that you want. Yeah, 2 + 2 is 7. That's kind of what you're saying. I can use any rule that I want. I can ignore logarithm rules. You can't do that. No, 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 can't do that. Can't do that. Excuse me. And then you guys know that there's a special base that's called E, log base E. It's called the natural logarithm. And then log base 10 is kind of a special number. It's called a common logarithm. And you've got buttons for each one of those. So log base E is this one here. And log base 10 is that one there. And if you don't have either one of those special numbers, then you'd have to go into your calculator and or a change of base. I think someone, Bonnie, one of our students in this class, excuse me, is has an 83. So they have to, and I taught them how to do the change of base formula. I think there was only one person. Okay. Now, today we're going to look at what's called equations. We're going to solve equations, find the value that makes it true. And if there's no value, like that's impossible, can't do it, then you say no solution. I'll say it one more time. That you've had a number of courses before this where you've had certain types of equations that had no answers, no solution, impossible. My baby algebra class have had those, so you had to have. I can think of linear, have no solutions, statements. You can have square roots, radicals. You could have rational functions that would have no solutions. And the way you would do it is you check it in the original. You check what you think your answer is in the original. So here, you always want to check, always check. Almost out of ink on this pen here. Okay, fine. Always check your answer. You think you get an answer, well, you better check it because it might not work. Answer might even be multiple answers. You'll find that out in the original equation. Now, if you don't check in the original and you go back to one step before the answer, it could work there, but you made a mistake along the way. So your answer works with a mistake along the way, but it doesn't work in the original. You got to check the original. Now, your author will go through certain techniques on how to solve certain problems. I have no problem having you use any of his techniques. None of them whatsoever. What I'm going to do is show you one technique for, these are called exponential equations, only one technique that'll work for any of them. Some of his examples says, oh, try this technique if it looks like this, and try this technique if it doesn't look like that for these. I'm saying I'm going to try one technique that works no matter what, guaranteed. But you can use his if you wanted to. Or I guess there's another one. Could you guess? That's a technique, I guess. I'll just guess the answer. I think we can all guess the answer here. 5, maybe 5. 2 to the 5th is 5. So guessing is a technique. I can't guess the answer here because there's no exact answer to this one. This one here there is, this one there's not. So I'm going to show you the technique that works for 1, 2, 3, 4 problems. Let's see. Harder, 5 problems, 6 problems. Okay, I have 6 problems. I'll do the same technique on all of them. It'll work. And check the answers. Then on log equations, like these, and like all these, so there's 6 of those. I have one technique. Oh, and there's 3 more back here. So it looks like there's 9 log equations. I have one technique that will work for all of them. He has 2, he might even have a third. So you could use his ideas. That's a good idea. Or you can just stay with mine, your choice. And then I think that's it. I think once I do these 3 back here. Yeah. Oh, there's a little word problem or 2 that we'll do, but I think that's all the basic. Yeah. basic solvings. All right, let's go to the one that I already know what the answer is. It's 5. I mean, the answer here is 5. So here's the technique. I'm going to log both sides. Now, I'm literally going to place the LOG on the left-hand side of this and the LOG to the right-hand, or the left-hand side of both things, like this. An LOG. These are going to be your arguments. So the LOG is base 10. I use base 10 because I got a special button that I get to use. You could use LN too, LN, or I'm just using the special button. So put the base 10 if you wanted to, but all of these are arguments. That side is an argument. LOG, this is an argument. I just got a tickle in my throat today. There's a 10 right here, right there. I don't have to write the 10. There's a 10 right there. I just want to make sure that 32 is not a base for you guys. Okay, so log both sides. Like this one here, I do the same. I'm not finished working these. I'm just going to set them up for you because they're all going to look the same. And so on. Okay, so now once you do the log to both sides, I'm going to use one of the rules or one of the properties that you had in your last section. Okay, here's the property I'm going to use. Got to find it. That one, the power one. Anytime I see a power, I slide it down in front. That's what I'm going to use. So I'm going to go back over here. Okay, not on that one, but that one. I'm sliding the X down in front. So here's my strategy. Slide the X down here, LOG, base 10. I don't have to write the 10, so I'm going to drop it off. Okay, LOG of 2 equals LOG log 32. And now solve for X. These are just stupid little numbers. Log 2, log 32, stupid little numbers. This is just a number that I can divide this side by LOG 2. Okay, got to make sure. You can't say log 32 over log 2 is log 16. Totally incorrect. You can't do that. So what do you do, Jeff? You just plug it in the way you see it. LOG 2 equals, well, let's see what it equals. So I'm just going to type that in my calculator. Okay, my little fraction thing that I like in my calculator looks like that. I go log 32, and then denominator is log 2. Hit enter. 5. I knew that. It's comforting to know that the calculator does the same thing. I knew that. I knew that one was the answer. Yeah, I'll show you. I could use LN. It'll do the same thing. It'll give me the 5 if I used LN. So it doesn't matter which button you use. I'll do LN. Okay, here comes the LN. LN, I don't know if you guys can see that. LN 32. Bonnie, can you see what I'm doing right now? Make sure that.
Yes, I can.
Okay. Is it zoomed in enough on the screen for you to see, by the way?
It is for me. Yeah.
Okay. and then ln 2. So instead of logs, I can do that. Oh, it's 5. Sure. So then you check. Okay, so I'm just going to mentally check 2 to the 5th, 32. Check. It's true. Okay, this one here, same idea. Bring the x down in front. Now, if I do a log on the top, I can't do a ln at the bottom. I can't, don't do, I know, I think most of you know that. Don't do an ln 2 down here because you're not going to get the right answer. You're not. So if you do log, you got to stay with log. So log, where's my log button? Okay, log 2. Oh, so this one's squiggly, squiggle, squiggle. And then you say, well, where, Jeff, do you round? I don't care. On your homework, your group quiz, let's say 2 decimal places. Pretty safe. On the exam, what you do, if you do this and you get that answer, you're just trying to match that up with the correct answer on the multiple choices, the letters. So if they do 3, then you're going to round it to 3. I'm going to round mine just for today, 2 decimals. So let's see, 90. Okay, I either leave that or make it a 1. So I see that. Okay, round that up to a 1. This is funny, Bonnie. I'm thinking right now, as I'm looking at this, first time that I'm really, I don't know, I probably knew it was there. You see the 0 with the slash through it, Bonnie? You see that, Bonnie?
Yeah, I do.
Do you remember what that's called in our classes that you were trained? And I'm telling my students right now about it. Anybody know what this? Go ahead. Oh, you can't see what I'm just wrote right here.
Is that one the null set?
That's right. It's called the null set, or the null, not statistically speaking, not in a stats class, but the null. Bonnie, do you know, do you remember, so you can tell everybody what this means? Does it mean 0?
It's the empty set.
Right. Okay, so I'm going to write this out as the null set. And some of you are saying, I don't know what you're talking about, Jeff. My instructor never said that. Well, if I sent out an email to all the math instructors at SRJC and I said, have any of you, I'll even say it this way, I'm taking a poll. How many of you have brought up every semester in either a 150 or a 156 class the null? How many of you have, and how many of you never, usually don't? And I would probably say a vast majority do. A vast majority of us do bring it up. It just doesn't register for a lot of our students because it's a little obscure. The empty, that's another one. Yeah, I like that. Set. Okay, Bonnie, you ever seen this?
Yep.
Okay, so this, these little squiggles are like set symbols, and all of you had to have seen. It's called set building notation. All the instructors teach both interval notation and set building notation. The textbooks do too. It looks something like that. You have a little something over here and you got a bunch of garbage stuff over here. So this is called set building notation. Those are set symbols. That's the empty set notation. And what's in there, Bonnie? What's right there, Bonnie, inside?
Nothing.
Right. Okay, Bonnie, is 0 nothing?
We zero is a number.
Okay, so, and I'll paraphrase what Bonnie said. 0 is something. 0 is a placeholder. 0 is a digit. 0 is something. This says absolutely nothing, invisible, empty, nothing. It's not the same. 0 and nothing in math, not the same. So just keep that in mind. So what brought this up, Bonnie, is I'm looking at the TI-84, and the display here has got a 0 with a slash through it.
I like that it's taken you until this semester to notice that.
I don't have no idea. And then look at here. Look at the 0 up here. Oh, shoot, fine. Right there. It doesn't have it there. So interesting, the programmers have yet to make that slash go away. I think that's crap technology. Now, Bonnie, do you have an 89 or a TI Inspire calculator by any chance?
I actually have the TI-84, the fancy one, really nice. Color screen. I recommend you guys get that.
Type in 0
I have
on your
this one
screen.
too.
Just the number 0 on your screen, and do you get a slash through your 0?
Yep, still get zeros. Still get.
Okay.
Still get a
Yeah.
slash
Okay.
0.
So just a little side note for the rest of you, all of you that are students in here. That kind of makes me smile. It kind of bugs me a little bit. I was trained 100 years ago in my accounting class. I took an account. I thought I was going to be an accountant before a math teacher. I thought I was going to be an accountant because I kind of like numbers, and I'm glad I didn't, because to me that would be a boring job, sitting behind a desk and working numbers. So I was trained, though, in my accounting class to do that, because we wrote everything in pencil. And this indicated to whoever looked at this is a number 0. Otherwise, it looks like the letter O. So it differentiates between 0 and O. I was taught in my accounting class to put a slash through the 7. I still do that most of the time, because otherwise it might get sloppy and look like a 1. A 7 might look like a 1. So, and the other one is my Z. I put a slash through my Z in my accounting class because it might get sloppy looking like a 2. Like, is it a 2? Is it a Z? So in a math class, I'm telling all my students, I said, break you of that habit, which sometimes it sets in and sometimes it doesn't. Don't think that's a 0 in math. It's not. Whew, that was 10 minutes worth of intensity. Squiggle, squiggle, 4.91. Is that what I think that was what ultimately, yeah, 4.91. Okay, this one here, what comes down in front? The entire power, but you need to put that in parentheses. The entire power, and then you go log of 4 equals log of 64. Okay, get rid of, this is what I do. I get rid of the log 4 like I have in the past. I'm left with the parentheses. Oh, now this one's a little extra piece. The subtract 2 has to go away over here to the right. So all you do is just like algebra, add 2 to both sides. So you got this fraction here you got to leave alone, and then put a +2 at the back end. So this looks like x equals log 64 over log 4. And at the end you go +2. And then let's see what we get. Oh my gosh. Five. Okay. Exactly 5. Okay, I wonder if that's true. All right, so you go over here and say, well, plug in a 5. What? Oh, right here. Okay, 5 subtract 2 is 3. 4 to the third, 64. So that looks like a good one. So Bonnie, I'm going to leave you this one.
All right.
Work out with the students.
The TI-89 puts a dot, a dot in the middle of the 0.
Well, you know, that's actually, that's better. It's kind of weird, but it's better. I don't know, why do they put the dot? I have no idea. It's only something I guess I could call Texas Instruments and say, what are you guys, why do you guys do that? So, but a dot, I like the dot better personally.
I hadn't actually noticed it before. I don't know why, but I guess your brain just kind of sees what it expects to see.
Yeah. Okay, this one here, a little more, I don't know, interesting. But I still do log. Oh, let's do ln just for fun, because I can do anything I want. Ln. Let's do ln of, okay, 2 raised to the x equals ln of this. All right, now I've got 2 sides. I'm going to bring down the powers to the left, 2 of them. So x ln 2 equals, okay, this one here, parentheses, x subtract 1 ln of 3. And your job is to solve for x, but see, x is on opposite sides of the equal sign. You got to get them together somehow. So a little bit more work on this one. So my suggestion is take that. We're going to distribute. We're going to break down the parentheses. So you got x ln 2 equals x ln 3 minus ln 3. And now I'm going to get the x's on the same side of the equal sign, which will be to the left is what I'm choosing. I'm going to take this and move it over to the left. So I have x ln 2. Now moving this one over this direction is subtracting x ln 3. So I took this one with the x and moved it to that direction. And then I still have equals minus ln 3 or negative ln 3. And now there's a little trick that we're going to do. And Bonnie can probably attest to this too. This little trick, and even in calculus, comes back up. In the algebra portion, when you do the calculus, oh, I got to do calculus, but how do I do the calculus? I have to deal with the algebra before I can do my calculus. It's the algebraic trick of factoring. So if I factor off the x.
Calculus is probably 80 or 90% algebra.
There you go. Algebra with some trig, right?
And yeah, algebra and trig, yeah, with like maybe 10% calculus, actual calculus operations. It's mostly algebra.
And do you remember doing this little trick at some stage with a problem or two, whether it's 1A or
definitely. Yeah. You never know when, but it just shows up. It's
and it's easy to forget until the instructor goes, well, then we're just going to factor. Go, what? Where did that come from?
It's a super handy thing to recognize when you see it. You go, oh yeah, I'll just factor an x out. Otherwise, there's no way to combine the x terms. It's the only way you can combine the x into 1 so you can solve for it. So it's totally necessary.
What a mess. Looks like a mess. Anyway, all of this that's inside the parentheses is just a weird number. So I'm going to divide. I'm going to divide like here and over there. I'm hardly going to squeeze it in. I'm going to divide that by the ln2 minus ln3 to both sides. ln2 minus ln3. So that leaves me x on the left-hand side, squiggle, squiggle. And then I just got to carefully type that into my calculator carefully. If I haven't made a careless mistake, of course, I'll check the answer at the end. Let's see. Yeah, it looks okay.
Hey, Jeff, can you rearrange that expression?
Yeah, this one here over here.
Yeah. Can you simplify that one?
Okay, tell me how you might think to do it.
It's not it's not jumping out at me. I'm wondering if you could just go through it real quick. Because it looks like everything is a ln.
Yes.
So we should be able to do the
Oh, down below. Yeah, okay, I see what you're saying. Sure, sure, sure. Separate piece of paper. Separate piece of paper. In the denominator. So let's see, in the denominator, numerator stays ln is what I'm thinking. In the denominator, if you've got 2 expanded, you squish it together, condense, compress, single logarithm as a quotient. So yes, Bonnie, you can do this. You can go ln parentheses 2/3. There's nothing I can do with those two right there, though.
Okay.
I can't like cancel the ln's and make that 3 and the 3's cancel, and I can't. This does not equal negative in just a single ln. Let's say 3/2/3. It does not, and I'll even prove it to you. This right here should give me about negative 2.71 if I did it right, because that was the answer I got over here. Let's go here, here, here. So negative. I said negative, but it's actually positive. 2.71. See, that worked. But if I did this, which some students think they can do that, there's a rule. If I go negative ln of, what would that be? What? That was weird. Okay, try this again. Negative ln. Yeah, that's what I wanted. 3 over, okay, 2/3. All right. Yeah. Oh, not the same. Not the same. So this is about the only thing I can see that I could do, Bonnie. That's all.
Okay, because the bottom is subtraction, and then the relationship between the top and the bottom is multiplication. So you can't just.
Relation to the top and the bottom. These two right here.
Yeah.
No,
Yeah.
it's not multiplication. You can't do anything with this. There's no rule that can squish a quotient of 2. The only rules that we have, and this is good for all of you to remember, here they are. There's only 3 rules. If you've got multiple, don't look at these, multiple logarithms, because that's what we had is multiple logarithms, logarithms. If you have an addition between 2, then you can do something. A subtraction between 2, you can do something. Or you've got this little power thing out here in front, something in front, you can bring it up as a power over here. That's all you can do. See, I don't see any log divided by a log. I don't see anything like that.
Yeah, exactly. Okay, well, thank you for clarifying that.
Yeah, it's a good review for even students here today as well.
Only when you're adding and subtracting them with each other, then you can combine the arguments.
See, look at this. Look what they did here, Bonnie. It's called a change of base. If the bases are identically the same, okay, now then you can squeeze it into one like this. But the bases, see how the bases change?
Mm-hmm.
So that would be interesting to see, like this. Let's see, how do I do that? Okay, these are E's. So this would be interesting. The negative stays, and that would be an ln. Base. This is weird. You can't do it. I can do it. Okay, hold on a second. This is log base E right there. So base. Log base this of that. I think I got it. Negative log base 2/3. Okay, interesting if this could work, of 3. That would be interesting if that gives me my, oh, that's going to be a negative though. You got me thinking now. And the rest of the students are saying, let's just move on, which it's true.
Yeah, sorry guys, my bad.
No, that's good. This is going to be a negative, so that's a problem. But I'm wondering if I just put this in without the negative, if I get 2.71. Let's see, this, that, no, base. I need that log base. Math. Oh yeah. I showed the students how to find the log base thing in here too, Bonnie, under the math button. So I can type in whatever base. Now 2/3 is allowed as a base because it's positive. And over here, I put a 3. Hey, that is weird. Oh, look at it. It's negative. And so the negative cancels.
You do get a 2.71.
I'm doing the happy dance. Look at that. Whatever dance I can do. This is true. The whole thing is true. This is squiggle 2.71. So Bonnie, there is a way of doing it, and it's called the change of base. So
all right,
you go. I'm happy that you were able to figure that out. So thanks for asking the question. Okay, now that was the Bonnie and Jeff show for a moment. Bonnie, you do this one too. If people come to your session afterwards. Okay, this one here, I'll do a few of these and then Bonnie will do the rest of them in her room. Let's see, you're going to change it to an exponential. Now that's the strategy that I do. Change this to where there's no logarithms. So I always start with the base. What's the base? It's a 2 in this one. What's the base? So I start with a base of 2 raised to something. It's either the x or it's the 5. I'm going to tell you what it's not. If these are connected here, they're not connected down here. That's how I remember. It's not going to be the x here. It's not. Oh, that means it's got to be a 5. The x is over here on this side. So supposedly x equals 32 is the answer, and I can check that. Log base 2 of 32. I wonder if it log base 2 of 32. Log base 2 of 32. Yep. Gives me 5. Check. Bonnie, you can do this one. Same idea. Okay, let's see. Bonnie, you can do this one. let's see what's the other ones on that backside. I'll do this one. This one here, you need to make sure that, well, here's what I'm going to do. It's a log base E. This is the little trick. Equals 1. That's a log base E. So if I were going to change it to exponential form, that would be E, base E, raised to the 1 power is equal to X. So there's an exact answer, or approximation is 2.71-ish. Bonnie, you can do this one. I'm going to give you a little hint for all of you. Move 9, then the 3 before you do the little thing that we're doing, Bonnie. So move the 9 first, and then move the 3, and then you can do the rest of the problem like we've been doing along. Change it to exponential form. Does that make sense, Bonnie?
Yeah, I think so.
Okay. Okay, this one here. Now, what's different on the rest of them is there's multiple logs. There's only one log here, one log, one log. This one's got 2 logs. So you want to squish it together using a rule. Squish it together. The sum turns into 1 log as a product of the arguments. This here would be log base 2, and then you've got the x minus 1 times x equals 1. And that's one big fat argument right there. And then exponential form, exponential form, then looks like this. 2 to the first is equal to the argument. And now you solve. And you solve by distributing to distributing. Now, it feels like it's going to be a quadratic. You might have to solve and factor. You might have to solve and quadratic formula. It looks like I'm going to get 2 answers. This is the one that's really important that you check both answers, because most likely one will work, the other will not, most likely. I didn't check my answers on, well, I don't know, this one here. This will be easy to plug E into here. ln E is 1. It will work. But here I'm going to check my answers as soon as I do a little algebra. 0 equals x squared subtract x subtract 2. 0 equals, I think this factors. Therefore, x equals 2. For this one, x equals 2. Algebra, set this equal to 0 and solve for x. X equals 2. Set this equal to 0, solve for x. X equals -1. Big fat question mark. I wonder if it's true. Where do you go? Original. Check. I'm going to check that one there. Original. You go log base 2. 2 subtract 1 plus log base 2 of 2. Question is that 1? That's the question. Is it 1? Log base 2 of 1 is 0. This is going to be 0. That's going to be 1. I'll show you. Typing it in, I'll actually prove it to you, but I just know my rules off the top of my head, which you guys are getting better at as well. Log base, okay, so log base 2 of 1, 2 minus 1 is 1. And then I go plus, and then math again. Log base 2 of 2. Hit enter, and I get 1. This one worked. If you plug this in, -1 to here and there, I'll just plug it in here and you'll see you're going to get an error. If you plug this in and even try that piece, second, no, second, math, that one there. I'm going to put in -1 just for that piece. Both pieces will fail, but just that one's good enough. I'll put log base 2 of -1 because you can't have a negative number in the argument. It'll say error, bad answer. Multiple choice test. I like picking problems like this where there's 2 answers or something is a bad answer and you wouldn't even check it. You'd think, oh, both of these are good. And there'll be a letter B, let's say letter B on the choice. Both of these are good. And you're going to pick that and it's going to be wrong. The only one that works is that one. You don't say no solution because there is a solution. That's that one right there. So be careful. Watch plugging it in. Okay. Oh, what a mess. Okay. What a mess. What a mess. What a mess. Bonnie, I'm going to let you do this one. I'll give you a little hint. How to push these together is a quotient of the argument, Bonnie. You got that idea?
Yep, looks good.
Okay. Now, which one of these do you want to do, Bonnie? And I'll do the other one, and then I'm done for this morning.
I'll just let you choose.
Okay, I'll choose this one. So Bonnie's this one.
The bottom one's easier, right?
No. This one should be easier. I mean, 1, 2, 3 logarithms. You got 1, 2, 3 logarithms and an extra piece. So it's a little bit more than mine, but it's pretty close. Okay, here's what you guys got to do with multiple logarithms. Bring them all to the left. This is the way my strategy is. Bring them all to the left-hand side of the equal sign. All of them. I think I'll do it this way. The author does it slightly different. Let's try this. LOG 3x minus 3 minus LOG x plus 1 minus LOG. What? That is weird. Can't do this one. There's a weird typo right here. I've never noticed that. Okay, Bonnie, don't do that one. I'm doing this one because I don't know what I'd have to do there. So you got out of that one.
Darn.
Push those together. LOG base 2 x subtract 3 times x. Subtract LOG base 2 of x plus 2 equals 2. Push these together as a quotient of the arguments. Log base 2 of, okay, I'm going to go ahead and distribute this. And that's all over x plus 2. Okay, now it's pretty messy, but watch what happens. 2 raised to the second power, 2 raised to the second power is equal to x squared subtract 3x all over x plus 2. And Bonnie's going to finish. And I'll tell you what to do, Bonnie, on this one if you finish. Bonnie will finish. Now I'm just looking at time. That's 4, of course. You're going to clear denominators, Bonnie. So multiply both sides by the LCD. And then you go through and factor and solve and check the answers and see if any of them work. So does that make sense, the process, Bonnie?
Mm-hmm. Sounds good.
So Bonnie will finish. Okay. All right, I'm going to open up your Canvas. Let's see, number 9 here. Okay, check it out. See, oh, I better check to make sure it's a good one. I just opened it to make sure it's. I'm going to look at it myself right now. Yes, property, 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 property. Oh, those are not hard. Those are, oh my gosh. Yep, if you've been doing your homework, you'll find out that probably take you 5 minutes. Anyway, do you guys see it open? It's number 9. Yeah, daily quiz number 9. Okay. So I'm going to, those of you who want to stick around, I'll put you in breakout rooms. If you want to leave, then you do it on your own. I'll leave this up for, I'll say, for the rest of the day. But sometime tonight, I'm going to shut it down. I'll give you guys score. If you don't get it into me by, I'll say, probably 6 o'clock, you'll get a 0. But if you want to stick around, I'll put you in breakout rooms. Afterwards, Bonnie will be around in her Zoom room. Bonnie, you want to put the link? Where's
It's
Bonnie?
on the announcements page.
Oh, there you are. Yeah, in the chat room, maybe, if you got
Right.
just as a friendly reminder for everybody. So her link will be in the chat room if you need to go see her. So let me get you guys in breakout rooms. I'll put you in with 4 or 5 people. Let's see who's here. Oh, I'm getting people leaving. Okay, hold on a second. Okay. Oh, people are leaving. All right, I'm not gonna do the breakout room yet until I see who's. Okay, give you one more chance before I make the rooms. Okay, hopefully everybody else wants to stay. All right, what's going to break? All right, let's see. Yeah, move. Okay, groups of 3 or 4. That's what it's come down to. Okay.